Hi everybody. Let's start our study of Chapter 5, The Time Value of Money. But before we get started with this series of video lectures, please have various materials available for use during the lectures. First, make sure you have your textbook open to the page that we'll be talking about, page 239 in this instance. Also, I'd like you to flag the 6 present value and future value tables located at the back of the textbook. They look like this. We will be flipping back and forth between the chapter and these 6 tables, so you should flag them for easy access. Table 1, Table 2, Table 3, etc. We will be using all 6 tables eventually. Also, you should have a paper and pencils and erasers handy because you will be asked to work concept check problems throughout the videos. And you could skip those. I know many people will be tempted to skip them because it'll make things go a lot quicker if you don't have to bother with the calculations. But that's the whole point of the video, is to learn how to do those calculations. So if you skip the calculations, you're going to be cheating yourself of an important learning opportunity. So please take the time to work the concept check problems. So let's start. The time value of money means that money can be invested today to earn interest and to grow to a larger dollar amount in the future. For accounting purposes, we use the time value of money in valuing a variety of assets and liabilities. So $100 invested today at 6% will yield $106 in the future. Interest can be defined as money, the amount of money paid or received in excess of the amount of money borrowed or lent. Interest can be calculated as simple interest, which means the initial investment times an annual interest rate times a period of time, or it could be calculated as compound interest. Compound interest includes interest not only on the initial investment, but also on the accumulated interest earned in previous periods. In other words, compound interest pays interest on interest. Let's do a simple interest calculation. What is the simple interest earned each year on a $1,000 investment paying 10% interest? Well, it's easy. $1,000 times 10% times 1 year is $100. It's going to be the same calculation every year. You will not pay interest on interest for simple interest calculation. So interest earned, let's say for 3 years, would be $1,000 times 10% times 3 years, or $300 of simple interest. Let's take a look at an example when interest is compounded on an annual basis. In this example, Cindy Johnson invested $1,000 in a savings account by paying 10%, or the savings account pays 10% interest compounded annually. How much interest will she earn in each of the 3 years, and what will be her investment balance after 3 years? The first year calculation is similar or exactly the same as simple interest. 10% times $1,000 for $100. Her account has grown from the $1,000 then at the end of year 1 to $1,100. When we are working with compound interest, the interest on year 2 is calculated on not the initial $1,000 investment, but on the $1,100, consisting of the $1,000 plus the $100 we earned during year 1. So interest in year 2 would be $110, 10% of $1,100, and interest in year 3 would be $121, or 10% times $1,210. So over the 3-year period, she would have earned $331 of interest, and her account balance would have grown to $1,331. Most banks compound interest more frequently than 1 year. More rapid compounding has the effect of increasing the rate of interest, and that increased rate of interest is called the effective interest rate. In situations when compounding periods is less than a year, the interest rate per compounding period is determined by dividing the annual rate by the number of periods in the year. So, for instance, if we assume an annual interest rate of 12% and we compound the interest semi-annually or twice a year, then we will calculate interest every 6 months at a rate of 6% twice during the year. Quarterly compounding means that we would calculate our interest at 3% 4 times during the year, and monthly interest means that we would calculate the interest at 1% 12 times during the year. Let's take a look at compounding interest for Cindy Johnson. Cindy Johnson invested $1,000 in a savings account paying 10% interest compounded twice a year. What will be her investment balance at the end of the year, and what is her effective annual interest rate? After the first 6 months, we're going to calculate $1,000 times 5% for $50 of interest. Add that to her initial balance, and you have $1,050 balance in the account. At the end of the second 6-month period, which is the same thing as at the end of year 1, we're going to calculate 5% times $1,050 to equal $52.50 of interest for that 6-month period, giving her a full year's worth of interest of $102.50 and an ending account balance of $1,102.50. Her effective annual interest rate is 10.25%. The $102.50 interest that she earned divided by the $1,000 initial investment, her effective annual interest rate is 10.25%. And here's a problem for you to work. Please pause this video and do the calculations necessary to answer the following question. Jacob Lee invested $600 in a savings account paying 8% interest compounded twice a year. What will be his investment balance at the end of the year? Round to the nearest dollar. Did you calculate $649? If not, please pause the video again and review the calculations shown here. A few minutes ago on slide 5, we looked at an example where Cindy's investment of $1,000 grew to $1,331 after 3 years. But look at all the steps we had to go through in order to calculate the future value of Cindy's $1,000 investment. Year 1 calculation, year 2 calculation, year 3 calculation, etc. Wouldn't it be cool if there was an easier way to do these calculations? Well, guess what? There is a simpler way. In order to do these calculations quickly and effectively, we'll use Table 1, the future value of $1, located at the back of your textbook. The way this table works, and all the other tables as well, is that the number of periods that we're calculating interest for is referred to as n equals number, and the number of periods runs down the left side of the table. A variety of interest rates run across the top of the table. So to calculate Cindy's interest for 3 years, the number of periods is 3, and the interest rate was 10%, we're going to run this row over until we find the intersection of row 3, and the column is 10% interest, and we come up with a factor of 1.33100. So we're going to take Cindy's $1,000 investment and multiply it times this factor, 1.33100. And when we do that, we calculate her future value of that $1,000 as $1,331. That amount is the same that we had on table or on slide number 5. And here's another problem for you to work. Oliver Kim invests $5,000 in a bank account earning 8% interest compounded annually. How much will he have in his account in 4 years? Hint, the future value of $1 at 8% for 4 years is a factor of 1.36049 per Table 1. Let's take a look at Table 1. Table 1, n equals 4, I equals 8%, a factor of 1.36049. Go ahead and do your calculations, and then start the video again to check your answer. Did you calculate $6,802? Answer C. If not, pause the video again and look at the solution that's provided on this slide. Well, that's the end of our first video. In our next video, we'll be talking about present values. See you next time.